Okay, as we look at scientific notation, some rules with scientific notation. There's lots of ways to write stuff. Engineering notation, monetary notation. Scientific notation is a little bit different. Okay, the first thing you have to understand is there's two things that have to happen in scientific notation. First, there is one non-zero digit, so one digit. Then you get your decimal. Okay, so one non-zero digit, so 1 through 9. Decimal, something else happens. And the second thing it's going to give is a dead giveaway about scientific notation is you'll see times 10. And times 10 is just a decimal shift. And we'll come back and comment about that here in a second. And then it will be raised to an exponent. All right, so you'll see these things. Now, the most popular number in scientific notation, or one of the most popular numbers in scientific notation, is Avogadro's number. And Avogadro's number is 6.02 times 10 to the 23rd. And this is how many atoms has to be gathered and able to make up 1 mole or one something of a substance in order for us to mass it, if you will. All right. Well, this is a huge number of atoms. So this actually has a number, and yes, it is a decimal shift. So when your teachers used to tell you, oh, all you have to do is it's a positive 23, so it goes to the right 23 spaces, that's true, because 23, if you take 10 times 10 times 10 times 23 tens all times each other, okay, it's going to make that decimal get bigger, that number get bigger. And the only way to do that with a decimal shifter by times 10 is by going to the right, okay? And that's for another lesson. So when we do this number, it becomes 602. That's 2 digits. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3. So, in Avogadro's number, it takes this many atoms to make 1 mole. As you can see, that is quite substantial. But to truly understand scientific notation, a number this big is very, very difficult to understand. So we're going to give you some more examples of some smaller numbers and how to manipulate through scientific notation to standard notation, or the way we typically write numbers, and back and forth between them. Okay, so let's take a number here. Let me get my different pen here. Let's take 1900, 1900. And I'm going to change it into scientific notation. And as you recall, we have to make this 1 digit, then decimal. And now we can forget about the zeros because the zeros behind don't really matter. So times 10. And how many places did my decimal move from here to get to this guy? Well, if it doesn't have a decimal, it's always got a decimal at the end. So it moved 1, 2, 3 places to get over here between the 1 and the 9. So it moved 3 places. And then you have to kind of be careful, because make sure that scientific notation is that standard notation form. They have to be equivalent. Otherwise, our math process kind of is messed up. Okay, so if I take 1 9/10 times, in this case it'd be 1,000, I'd get a number fairly close to 1,000, or closer to 2,000. And this number is very close to 2,000, so we can estimate and look at that. So let's look at another number. Let's go 0. Number in standard form here. I'm going to change it to scientific notation. And here again, it is 1 digit, decimal. The zeros in front or behind of these guys, doesn't really matter, times 10. That means it's a decimal shift. And from this decimal, it moved 1, 2, 3, 4, 5 places. However, it came from a different side of things. And in this case, I have to make it negative. And if your teacher reminds you of, from scientific notation to standard form, the negative makes the decimal place go to the left. That is true, but it's because of an exponential rule that actually now we're taking 1 4/10 and we're dividing it by 10 and a positive 5. So as our decimal shoots to the left to divide that guy on the bottom, it will also do it on the top. And here again, you'll catch that in another lesson some other place. So just so you understand, that is, and there is a reason behind it. Now, let's go to another one. Let's do this in a different color maybe. And I'm going to go from scientific notation. So let's go 3 5/10, 10 to the negative 4. And I want to take this and change this into standard notation, or how we typically end up writing numbers. All right. So we have to understand that the negative is going to make it go to the left because we're dividing. That number's getting smaller. So I'm going to write 35, and then this time I'm going to write it out here. And the decimal was right here, right? So it goes 1, 2, 3, 4 places. So see how I went 1, 2, 3, 4 digits now is how much that thing moved because of the 4, and moved to the left. And I like to put a 0 in front of that because as a youngster, boy, that decimal used to do all sorts of things. And if I didn't put it out in front, I'd multiply it or do something silly with it. So I like to have the 0 there. It pretty much just accents that decimal. Let's do one more here before we call it a day. 3 8/10 times 10 to the 11. And again, we're going to go into standard notation with this, or as a real number. And now this number here gets bigger because if I take it times 10, I get 38. If I take it times 100, I get 380. Well, I'm taking this number, I've got 11 of those 10s all times each other. So this number is going to get bigger, which means my decimal shift should be to the right. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And please come back and put your commas. That way we'll know how to name that guy in future lessons.